today's video, we'll be learning about unit rate conversions. Dimensional analysis is a commonly used rate conversion technique. Let's look at this technique through using the formula d equals r times t, the distance formula. Let's say we're given a rate of 10 meters per second and a time of 1 hour. We can plug these into the formula and attempt to get the distance. So d equals 10 meters per second times 1 hour. And when you're doing these types of problems, you can treat the units meters per second and hour, or whatever unit you're working with, as variables. So when you multiply, you get 10 times 1 is 10, and meters per second times hour is meter hour per second. Now this unit doesn't make sense, and to fix this, we need to use the dimensional analysis technique to convert 10 meters per second into 10 meters per hour. So if we, it's not going to be 10 meters per hour, but when we convert it to meters per hour and multiply by the 1 hour, which has a unit of hour, the hours cancel out and we're left with meters. This is the unit we want to find the distance in. So let's convert 10 meters per second into meters per hour using the dimensional analysis technique. To make this easier to read and visualize, I'll do it in a chart type format, table type format. So 10 meters per 1 second. That's the rate. Now we need to convert this into the meters per hour unit. So we don't need the seconds right here. We need it to cancel out. And we know that diagonals cancel out right here. So we need this to be some number of seconds, and we need the bottom to be hours. And when we multiply, we know that the bottom, if the bottom is hours for the second section right here, when we multiply it to 10 meters per 1 second, we'll get hour at the bottom as well. So the bottom needs to be hour. Now we need to look at the relationship between these two units. So for every 1 hour, since we're looking for meter per hour, there's 3,600 seconds. And now the 3,600 seconds and the 1 second, they're diagonal. So since we're treating them like variables, the seconds cancel out. And this is what we're left with. And all you need to do as a final step is to multiply 10 to 3,600 to get 36,000 meters per 1 hour, since the seconds cancel out at the bottom. This is our rate in meters per hour, which we can now use to find the distance. So now when we plug it into the distance formula, we get d equals 36,000 meters per hour times 1 hour, which is 36,000 times 36,000 times 1 is 36,000. And when we multiply meters per hour times hour, the hours at the bottom of meters per hour cancel out. So we're left with just meters. So 36,000 meters. How many seconds are there in 1 day? Now this is a really simple problem, but this will give you an idea of how to work with more complex unit conversions with more than 1 unit. So we have to convert from 1 day to seconds. So we need to cancel out the day here. So 1 day again. And the next smallest unit is hours. So hours, there's 24 hours in a day. Days cancel out. We need the hours on the bottom too, since we're not yet at seconds. 1 hour. And the next smallest unit is minutes. So there's 60 minutes in 1 hour. This results in the hours canceling out, and we need seconds. Minutes does not work, so minutes goes at the bottom. One minute. Next smallest unit is seconds, which we want, so there's 60 seconds in 1 minute. The minutes cancel out, and the only unit we're left with here is seconds. So we do 1 times 24 times 60 times 60 in order to get how many seconds there are in a day. And when I put that into the calculator, we get 86,400 seconds in a day.